But we have a Hall effect sensor, so it reads the magnetic field and outputs it to a voltage, so that's what we see on the screen there. One thing we didn't get to is soldering it onto here, so we just have it on a breadboard. You know, the boys will know breadboards and all that. So we'll give you all that, but we had this purchased to solder everything on as a solid circuit, because it's just temporary connections right there at the moment. So yeah, that was that. Over here too is the LiPo battery charger. Like I said, we went with the batteries because we knew it would give us any current we needed. Because as you start to go higher in DC power supply, it gets more expensive. So instead of buying something we didn't need, we could test it, and now we can figure out the current draws, and then the right power supply can be given or purchased accordingly, planned out accordingly. But yeah, we have this battery charger, so we preset some settings in there, so it'll be easy to charge up, and we'll give you a rundown of how to, you know, the settings. It's really simple. We already programmed. But
I don't know about the connection. I should not make any thing in the connection. It is that's it, connected as it.
This is it. You just plug it in. Make sure we have this adapter here. Whenever this is being charged, plug these in first and then plug that in, because we don't want to plug this in and then the two ends touch after. So you just plug these in first before attaching that. And here's a little
approximity.
That's a balance connection. So what that does, it reads every LiPo cell in the battery and charges it balanced, so it doesn't charge different cells at wrong times and all that. And you can look through it, and it tells you the voltage on each cell and the percent that it's full. And
there is manual or something?
Yeah, we have the manuals and everything, and there's some other documents.
Yes, I need this document, please. This document, and also the know-how for how this is built.
We will
all data.
Have some documents that'll lay it out as far as using it, and really simplify it. Like I said, we did put some stuff in there already, so that's taken care of, and all that. What else? We got a couple extra parts here. It was good to have a couple extra. The machine shop didn't do anything, so we ended up putting this together ourselves.
It is enough. It is enough. More than enough.
The original is to be out of all this plastic. So for presentations, you could really see what was going on. But because the complications, we put it together with wood. But like I said, we have extra plastic, and these can be taken apart, and as things become modified. And for demonstration, we were worried about safety of people as well.
And regarding to this connection, I don't know.
Well, this is
the connection's actually. The connection's actually only this little bit. This is just another project I have on the go. So
So this is not mine. This is not mine. This is not related to me.
We were going to give you the sensor.
The sensor and the capacitor there. Is that?
Yes.
And we have schematics on.
I can't. I think I can't use it. I can't use it.
Well, we can. Any oscilloscope, anybody with electronics, like any of your guys, would have oscilloscopes, I'm sure, as well. That's to see the waveform. This is something we got with the school when we started the program. So we had it handy and used it for the testing.
Okay. Anything I don't get benefit from it? No need.
Well, that's just kind of a testing thing. It wasn't something we should buy in a oscilloscope.
No need for something I don't need. I get benefit. I get benefit just from this one.
Yeah. So
yes.
It's
yes.
it proved the theory.
Yes, this is the most important thing.
Yeah.
This is the most important.
Yeah, it was good. So we satisfied the 30 hertz signal.
Yeah.
Starting to make a square wave, so we figured out how to start doing that.
Yeah.
One thing we didn't get to test was the unipolar.
Yeah.
But we have an idea for that. If we had the magnet and we put the north side facing that way, right on top of the steel core that's in there, we were hoping that as it's rotating, when the south side of the magnets are in the center, it would pull the south up towards the magnet, and then only the north would get out that way.
Yeah.
So we're hoping to have that.
You not confirm this point.
No, we didn't get to confirm that, but yeah, we have some lab reports as well. We didn't get to fill out because of the time that we had, but there's 6 lab reports and charts made up to record data in.
Okay.
That we put together. So different phases of it would be, and it was to help figure out the forces that the magnets make when they interact, when they're spinning, so that way you can calculate the proper power supplies needed and stuff like that. But one is without the magnets attached, one is with the magnets attached, one was just the motors. Anyway, there's an outline of it as well. There's the 6 reports we'll be putting in the report, and we'll give it to you as well. And
when you think the report will be ready? When it's on time?
The report?
Yes.
So that's due Friday for us. So then we can give you the whole thing right after. Yeah.
Friday?
Yeah.
After Friday.
Yeah.
After Friday.
Yeah.
Oh, okay.
And then.
And all these are deliverable by mail, by email.
Yeah.
By email.
Okay.
Yeah.
We should be able to do that. Yeah. And then also besides the report, there's extra documents we can give you that we have, and we have a whole bunch of stuff. So it's all in a group drive, and we'll give you more documents besides what's in the report. And, because you can fit so much in a report, but there's some things that might be easier to explain. And,
how do you think we can synthesize one like this? How can we make mass production? This is just a prototype.
Yeah.
Mass production, how can we?
So there'll still be some steps to go through. Figuring out the intensity as well. Possibly some mechanical type engineering. To see how many magnets we can put, because one of them in there is going 9,000 RPMs. So there's a certain speed limit you can probably hit with the magnets, but that's how adding up the odd harmonics works to make a square wave. So I would recommend some mechanical engineering for that type of thing, and then once that is figured out, really miniaturizing it to what you want, and then going from there. So there's a couple steps still to see, I'd say.
We actually didn't make it the field as strong as we could make it. We kind of set it to our sensors so that we could get a good reading, but the strength of the wave is established by the distance of the first magnet, the first frequency magnet, and it's, I think, about a centimeter away, but you could move it a lot closer and get a stronger field. So you definitely would want to do that for your final device.
Yeah, and then there's also another.
It is how many Gauss now is this?
I said it was
200 milligauss.
200?
It was it was in the milli, like I think it was 200 milliteslas or something like that at the face. So it's not. That is one of the weaknesses with it. It isn't very strong necessarily, but you could definitely increase it by
increasing intensity.
and using stronger magnets.
Okay.
Yeah.
So as like stronger or bigger magnets are used, then running through the same procedure, because you'd have to see how much current those draw as well, and if they produce extra forces and stuff like that.
Okay.
So as stronger magnets are used, kind of have to experiment with that as well to see what the limits are you can do with them.
Okay.
Anyway, what else was